Good morning, students. Today we will start with exercise 15.2. In this, we will be learning about areas of quadrilaterals and polygons. Trapezium, as you all know, we have studied in the previous class also that a trapezium is a quadrilateral with one pair of opposite parallel sides. Okay. The area of trapezium is given by sum of half into sum of parallel sides into distance between them. Suppose that here it is, these two are parallel sides and the distance between them is h. So it is given by half into sum of parallel sides into distance between the two parallel sides. Now in general, the area of quadrilateral is given by the formula half into d h1 plus h2, where h1, suppose that abcd is a quadrilateral, okay, and ac is the diagonal, okay. In this now what do we find? That it is split into two triangles. Now suppose in triangle acd h1 is the height, and in triangle bc abc h2 is the height, and the distance between the two opposite vertex, that is a and c, the diagonal, is d. Then it is given by half into d h1 plus h2. Now the area of rhombus is given by half into product of diagonals. Means suppose AC is diagonal 1 and BD is diagonal 2, then it is given as 1 half into D1 into D2. So we'll be using this formula in solving exercise 5.2. So let us start. Sorry, 15.2. Question number 1. Each side of a rhombus is 13 centimeter and one diagonal is 10 centimeter. Find the length of other diagonal. So let us solve it. So first of all, we'll make a figure. So it is given that each side, we know that rhombus is a quadrilateral whose all sides are equal and the diagonals bisect at right angles, isn't it? So each side is given 13 centimeter and BD means one diagonal is given 10 centimeter. We have to find out the length of another diagonal, means we have to find out the length of AC. Okay. Now we know that the diagonals of a rhombus bisect at 90 degree. So each triangle is also a right angle triangle, isn't it? Now, since BD is equal to 10 centimeter, now it is bisecting. So, OB will be equal to OD. So, OB and OD will be equal to 5 centimeter. Now, let us take any triangle. Let us take triangle COD. Now, in this triangle, it is a right angle triangle. So, we will use Pythagoras theorem. We don't know OC, isn't it? So, we have to find out OC. We will be using Pythagoras theorem, that is CD square is equal to OD square plus OC square, or OC square equals to DC square minus OD square. Just put the value. DC is 13 and OD, that is equal to 5. So DC square minus OD square, that is 13 square minus 5 square is 144. So we will find out OC, that is under root 144. We know that it is equal to 12 centimeter. So OC is 12 centimeter. Now we know that diagonals of that it is bisecting each other. So if it is OC is 12, OA will be also 12. So it is equal to 24 centimeter. Okay. So the length of the diagonal AC is 24 centimeter. Similarly, you will be doing the next question also. Here, what is given? The area. We have to find out the area of the rhombus. Now, in this question, we have already got one diagonal 10 centimeter. We have found out another diagonal 24 centimeter. Now, what is the area of rhombus? We know that is equal to half into D1 into D2. Now, we just use that formula. We will get half into what d1 into d2, sorry. Now one diagonal is AC, another is BD, that is 24 into 10 divided by 2. Just solve, you will get it as 120 centimeter square. Let us start with question number 2. The cross section ABCD of a swimming pool is a trapezium. So it is a trapezium. So we see that the two opposite parallel sides are AD and BC. Okay, so these are two parallel sides and the distance between them is 14 meter. Clear? Now, if its width AB is 14 meter, depth at the shallow end is 1.5 meter and at the deep end is 8 meter, find the area of the cross section. So you can see that it is a trapezium. You can see it like this also. So these two are parallel sides and this is the distance between the two parallel sides. Simply use the formula half into sum of parallel sides into distance between them. That is half into So let us see, AB is equal to 14 meter, AD equals to 1.5 meter, BC equals to 8 meter. So it is in the form of a trapezium, you can see. So area of trapezium ABCD is equal to half sum of parallel sides into H, or distance between them. Now what are the parallel sides here? AD plus BC into what is the distance? That is AB. So that is equal to half into 1.5 plus 8 into 14. Just solve it. You will get it as 9.5 into 7, 35, 66.5 meter square. Now let us see question number 3. The area of a trapezium is 360 meters square. The distance between two parallel sides is 20 meter and one of the parallel side is 25 meter. Find the other parallel side. So let us draw the figure first. Now according to the question, this is a trapezium. Area is given, okay, and the distance between the two parallel sides is also given, that is 20 meter. Let us take it as AE, and the two parallel sides are AB and DC. Now it is given, one parallel side is given, we have to find out the other parallel side. So let us take this as 25 meter. We have to find out AB. You can take either of the two sides, so it's up to you. So area of trapezium is half into sum of parallel sides into distance between them. So in place of area, we'll just put the value 360 equals to half into AB plus CD into AE, or 360, just put the value 25 plus AB. We don't know the value of AB plus into 20 because our aim is to find out this side AB. Okay, so just solve it. 2 tens are, so it will become 36 equals to 25 plus AB, or AB equals to 11 meter. Okay, so children, for today this much only. Solve these questions in your copy and practice. Thank you.